Hi guys, let's now graduate on to doing some more worthwhile questions. We have done all the basic setups. We have understood what a tension is, what normal reactions are, how the constraints have to be applied, how the equation has to be made, how to make a equation of a body. Now this is a question which is better than the earlier one. Not a very difficult question. Quite easily it can be done. But the analysis part, I would request you not to skip this question because you know how to do it, because you can do it very fast is one thing, but just listen to the analysis and see what all aspects we can look into the question. So what I'll try to do is, mind you, this is a question what was already in the constraint motion we had already asked. If two motions were given, what is the third motion over here? And to go back to that part quickly, if this pulley moves by X and nothing else, this pulley is made to stay over there like a fixed pulley, then this goes down by 2X. And if this pulley goes up by Y, then again we'll have 2y loose string and this will go down by 2y if this is made stationary. So ultimately if this is going by x up and y up, then this is going down by 2x plus 2y. So that was your constraint motion thing. Now with what is going up and what is going down will be all dependent on how much is the mass. So what I'm saying is, let me put 2 kg mass to this body, 2 kg to this body, and a 3 kg mass to this body. Now I would ask you to analyze this situation and tell me by inspection, what do you think? This 2 will be going up or down, this will be going up or down, and this 3 will be going up or down. What do you think? Which way will they be moving? Just take a while and analyze, and maybe even an answer like can't say that it will be going up or down is also alright. But which one can you definitely say is going up or down? I guess you have done some analysis over here. So one of the key thing to analyze and understand, get into the situation is holding the correct body, holding a body and analyze what is happening. Holding the pulley or the body. So if I hold this body, then I look at this situation, then what is going to happen? If this body was also held, if this body was also held, then the tension, then everything is held. This is held and this is held. Then the tension over here would have been equal to the weight. The tension would have been equal to the weight. That is 20 newtons would have been the tension. And therefore this T plus T, the tension over here would have been 2T, which is 40 newtons, would have made the body, 3 kg body, go up if I release it. So if I keep holding it and release the situation, then the 3 kg body is going to go up because there is 2T tension, and a 4 kg mass would have countered that. A 4 kg mass would have got a weight of 40 newtons, and a 20 kg, 2 kg mass over here would have countered a 4 kg mass over there with this pulley. So 3 kg mass will not be able to counter, it will go up. Now suppose I hold this, I keep holding this and I release this, then this is definitely going up. Why it is definitely going up? Because 2T is going to pull it up. Your when it was held, when this was held and this was held, the tension was the weight of the body, which was 20 newtons, and when it is let go, when this one is let go, then the tension just before letting it go, the tension over here, this is still held, the tension over here was 20 newton and 20 newton, 40 newton. So when let go, the tension will release a bit, but then 40 newton is going to pull up that 20 newton body, and hence this body is going to go down. So in all probabilities, when I'm holding this and letting this go, it is going up. When I'm holding this and letting this go, this is going up. So in all probabilities, this is definitely going up and this is going down. This is going down with some acceleration. Say this was body 1 M1, this is your M2 and this is your M3. So this is going down with acceleration A3. When this is going down with acceleration A3, this body is going up. What about this body? What do you think is happening to this body? When the body starts going down, then the tension releases. So the tension which was acting when the body were not going was 2T, which was equal to 40, but then the bodies were held. This was held and this was held. That time it was 2t was 40. When it is let go, then what happens? The tension releases. The tension becomes less than the initial one. So the tension will become, T will become less than 20. Now the tension will be less than 20 for sure because it is let go. I have explained you earlier, when you let go, the tension releases. So if the tension has become less than 40, is it still more than 30 to take it up? If T is more than 30, then this body is going to go up. If 2t is less than 30, it is going to go down. I'm sure that t is less than 20. I'm not very sure of 2t is less than 30 or more than 30. So what I'll guess is 2t is more than 30 is just a guess, and we are going to analyze later. See for sure later when we solve the situation. So I'm just guessing that 2t, which was earlier 40, when the strings are let go, if the movements are not very fast, if the accelerations are not coming very fast, then this body is going to go up with some acceleration a2, and I might be wrong over there. There's a very high probability that this will be wrong. And this body is definitely going up with a1. One of my reasons of putting this A2 up is I will have a very easy relation between A1, A2 and A3. What is that? We have done in the constraint. What is that relation? I'll write it over here. A3 is equal to twice of A1 plus twice of A2. So this is making the string loose, 2A loose over here. This is making it loose, 2A loose. All of it goes and tightens over here by this dropping by 2A1 plus 2A2. Now let us make the equations and see whether our analysis was correct or not, and whether our thinking over here that the 2t is going to become less than 40, and it might become lesser than 30 also, and this body may go down if the movement is too fast, means if the acceleration is too much. If the acceleration of this body is too much, then the string is the tension has gone down by a big amount. If the acceleration of this goes up till g, then the tension would have become almost zero. If the acceleration has become very high, that means g. So that would be a case when these bodies were very light. These bodies are not very light. If this was all zero, then this would have gone down by g, and the tension would have been almost zero, negligible tension. So because it is free falling. But over here, these have enough masses, so I'm not guessing that there is such a big release of tension, and hence 2t might overcome 3g. So that is the analysis in this question. And doing the question is pretty simple. You take up bodies one by one. So we'll take the first body, 2 kg body, and we'll write an equation for it. And I'll stick to the variables m1, m2 and all, so that we vary the masses later on and see how the effect goes. So if I take the whole thing as a body, then 2t is acting on this t and that t. 2t is acting on the whole body. Pulley has been taken as massless, so 2 kg. Or you can introduce another pair of tension, 2t. And why is this 2t? I already explained you in the constraint class, but I'll just do a bit of explanation on that also. So if this was going up with A1, the pulley is also going up with A1. So if I want to write the equation of the pulley, so there are three forces on the pulley, T, and a new string, so some T dash, which I am saying is equal to 2T, but let's see. Say the mass of the pulley was M pulley. Say the pulley was having a mass. Then what's the equation? The pulley is going up. So the equation is 2T minus T dash is equal to mass of the pulley times acceleration of the pulley. Now here, if the question says that the mass of the pulley is 0, then what happens? This right hand side becomes 0. And what do you get? You get 2T is equal to T dash. So if the mass of the pulley is 0, then only this is 2t. This part is 2t. Otherwise it is not. Otherwise you'll have to write an equation for that body separately, as I've written over here. Or you can take the whole body as one, mass of the pulley and 2 kg mass, and the force on that as T and T, because both are going together. So internally this tension will not come as 2t if there is a mass to the pulley. So writing the equation, my first equation for body 1, it would be 2t force is upwards, mass, the weight of the body, m1g is downwards. So that's m1g is equal to acceleration, which is upwards, and acceleration is of the mass m1, so that is m1a1. That's my first equation. Similarly, I'll have an equation of the other body, which again I'm assuming is going upwards, even though m2g force is trying to make it go down. I'm assuming 2t is exceeding that. So 2t minus m2g is equal to m2a2. That's the equation of this body, or you can say this much. That's the equation. Here again, suppose m2g exceeds t and the thing comes as a2 comes as negative, then the only thing is that we have assumed, our assumption of 2t being greater than m2g is wrong, and it is the other way around. But mathematically the equation will still be alright, it will be okay. The only thing will be a2 will be negative, which as physics student you should hate getting the answers opposite to what you thought is happening. You try to nail the answer in the direction, if possible, in the direction what is going to happen if it is inevident. Like here and here I'm pretty sure this is going up and this is going down. Here is the dicey part. Now the third body, it is going down, so the downward force is m3g. You see it's a small weight compared to these weights, but then the tension is also small. It's just one tension. Here you have double the tension. So with a lesser weight, if this is what is happening, then with a lesser weight you are able to lift up so much of mass, 2 and 3, totally 5 kgs you are able to lift with a lesser weight, if this is what we thought is happening. So again, that gives you a good hint whether that can happen or not happen. You can write energy equations to find, but we are not on to the energy momentum chapter yet, energy and power chapter yet. So sticking to this and writing the equation for this body, what we get is m3g, the downward force, countered by tension, the upward force, is equal to the mass of the body torqued, which is m3, into acceleration of that. So what do we see? How many equations we have got and how many variables we have got? Let us count them. We have got 3 equations and the variables are t is a variable we don't know of, a1 is a variable, a2 is a variable, a3 is a variable. We have got 4 variables, we have got 3 equations, which is not good enough. So there comes our constraint, which is one of the basic equations. So we'll eliminate one variable, or we'll add an equation by saying that a3 was equal to twice of a1 plus twice of a2. So that becomes our 4th equation. So we see that we have got 4 variables and 4 equations to solve with. So in such cases, putting the numbers is a much faster way of solving it. So I can put the numbers and solve it for you, but just to get a taste of it, let us do it the hard way. Let us go on solving with the variables. So first of all, we'll eliminate one of the variables. Let us keep the variables as a1 and a2 only, and let us do away with a3. So what do we get over here? The third equation becomes, from equation 3, what we get is m3g minus t is equal to twice of m3 a1 plus twice of m3 a2. So looking at this equation, equation 1, equation 2, and this modified third equation, we have 3 variables, which is a1, a2 and t, and 3 equations. So our next aim would be to do away with one more variable. So what will we do? We can replace a a1 with a a2, or we can get all the things in terms of tension. So I'll try to cancel this a1, a2 with this and this. So how much is a1 from the first equation? a1 from the first equation is, from equation 1, it is 2t by m1 minus g is your a1. The second equation, from second equation we have your 2t by m2 minus g is your a2, which we can plug in over here, and what we get is this equation, the twice modified equation 3, m3g minus t is equal to twice of m3, it was a1 plus a2. So what is a1? 2t by m1 minus g. And what is a2? 2t by m2 minus g. So here we have an equation which has just t's in it. T is the only variable in it. So you can very well take out the t from here by putting all the t's on one side. So if you want, I can do it for you. So you have 4t m3 by m1 plus 4t m3 by m2 plus t, this goes on that side, is equal to m3g, this one, plus twice m3g, and m3g is 2g, so you have 4 m3g, so plus 4 times m3g. So what we are getting over here is all t common. We have 4 m3 by m1 plus 4 m3 by m2 plus 1 is equal to 5 m3g. So writing that equation, so you can take m1 m2 as the LCM over here and write your tension as T is equal to 5 m1 m2 m3g, that is your m1 m2 from here will go on top over there, divided by 4 times m2 m3 plus 4 times m1 m3 plus m1 m2. So that is the tension force what we get. So does this tension force exceed what we had thought is twice of this? Does it exceed this 3 kg? Let me put the values and see. T is equal to 5 times 2 into 3 into 2 into, say, G is 10, and at the bottom we have 4 times 2 into 3, which is plus 4 times m1 m3, which is 2 into 2 plus 2 into 3. So what we get over here is 2 cancels all over. So you have 5 into 2, which is 300 on top, and on the bottom we have 12 plus 8, 23. So we have got 23. So tension is 300 by 23 or 30 by 23 G. If I would have left that T as G, so that's your tension. Now twice the tension. First of all, is this tension less than 2G? Is this less than 2G? Yes, it is less than 2G. Hence, M3G is going down, tension is less. Is this tension twice of this tension? What is 2T over here? 2T is 60 by 23G. How much is that in fractions? It is 2 times, if I make improper fraction, gives 46. So 14 remains on top by 23G. So this 2T tension is equal to 2 point something times G. It is not equal to 3G. Meaning to say what? it is good enough to pull this 2 kg mass up. The 2T tension, which is 2T, which is 2 point something something G, is good enough to pull this 20 Newton weight up, but it is not good enough to pull this mass up. Your 3 kg mass, which has a weight of 30 Newton, is going to exceed this 2T, and this mass is ultimately going to go down. So what we'll have is A2 will have a negative value. That is what I'm getting from here, that A2 is going to have a negative value. Let me put it in this and see what we get. So 2T we have got as 60 by 23G is your 2T, minus M2G, which is 3G, which is what I was saying, that this 3G has exceeded the 2T value, and hence 3 times A2 is going to come negative because 3G has exceeded this value. So how much is 23 into 3? How much is that? This gives you 60 minus 69 G by 23 is 3A2. So 60 minus 69 is minus 9. So your A2 comes as 3 goes down. So 3G by 23. A2 is 3G by 23. It's a very small fraction of G. It is going very slowly but down because it has exceeded the 2T. So it is going down very slowly. So wherein A1 is still going to go up in the direction we had assumed to be the correct direction, because it is an extra 14 by 23 G remains. So this was 14 by 23 G was this 2T minus 2G is the net force over here is equal to 2A1. So 14 by 23 minus 2 gives you 14 by 23. So 14 by 23 G is equal to 2A1. Hence A1. So let me write over here. A1 is equal to 7 by 23 G. So A1 is correctly going in the direction what we thought. A2 is not. A2 is going in the opposite way what we have assumed. And we had so let's be done with it. A quick calculation of A3 also. So that's the acceleration of this, that is going down. It is going with enough acceleration such that the tension has released and it has become quite less such that it is not able to pull up, 2T is not able to pull up 3G. So that was the story. So let me do the calculation of A3 over here. So what we have is M3G minus T. M3 was 2G minus T, and T was equal to 30 by 23G gives you twice of A3. So what we have is 2 minus 30 by 23, so which gives you 46 minus 30, which is 16 divided by 2, which will be 8. So A3 will come as 8G by 23. So the situation is, this is going with 8G by 23. This is going up. A1 was 7G by 23. So almost with the same acceleration which it was going down, it is going up. It is going up with a considerable acceleration. It is going down with a considerable acceleration. It is almost 1/3 of G. It is going down with and is going up. So this has released the tension a lot, and hence this is going down very slowly. It is going down with, it came as 3G by 23. So this is going down with 3G by 23. So this is the situation. Now, okay, before I go on to the analysis, just a recap of the steps. First we wrote an equation for this mass. First we wrote for M1 mass 2T minus m1g is equal to m1a, acceleration of that one. Next we wrote for the equation of this mass, 3 kg mass, we wrote m2a, a2 being the acceleration of this guy, and for m3 we wrote acceleration a3, a3 being the acceleration of that guy. So we did not write a, that is one of the mistakes what you people do. A over here, f is equal to ma, is the main equation. F is equal to ma doesn't mean that A of all the bodies are same. A of all the bodies are different, forces on all the bodies are different, masses of all the bodies are different, m is different for all, a is different for all, f is different for all. So we have to write those individual a's. Those individual a's were connected like this, that is through the constraint we saw, and hence we had 1, 2, 3 and 4. 4 equations and 4 variables, 1, 2, 3, 4. So we eliminated them. So first this last equation was giving extra variable a3. So we did away with a3 by putting a3 as 2a. 1 plus 2a2, you can manage in whichever way you want. So we removed a3. So now we have got 3 equations, 1, 2 and 3. These 3 equations with 3 variables, those were t, a1 and a2. So next our plan was to do away with a1 and a2 all together in one go, because we can pick up a1 in terms of t from here, we can pick up a2 in terms of t from here, and we can plug it in this equation, the modified third equation. So a1 in terms of t, a2 in terms of t, no other a's, only t remains. So this equation gave only t's. So that was that equation, which has only t's in it. On a bit of rearrangement, there's the rearrangement steps, we did that and we got this. This is the equation what we got. Then we plugged in the values because we were quite eager to check on that the directions what we had taken was right or wrong. So we got it right in 2 cases, and our assumption of what may go wrong came right, and the body too was going in the direction opposite to what we thought it is going to. So that was the situation. Now why do I write in terms of m1 m2? My life would have been much easier if I had written the values, because I want the final equation to be analyzed. What I know is if 2 and 3 were not having any mass, tension would have been 0. It would have been going down as a free fall. So if 2 and 3 are massless, then the tension is 0. So if I put m2 and m3 as 0, I get tension as 0. Yeah, I do get that. Next analysis would be, had this 2 kg been a 4 kg mass, had this 3 kg been a 4 kg mass, and this was a 2 kg mass, then everything would have been properly balanced and nothing will move anywhere. The tension would have been 20 Newton in that case. Does it come? It would have been 2 kg in that case. Had this m1 been 4 kg, m2 being 4 kg, m1 equal to 4, m2 equal to 4, and m3 equal to 2. Why do I say that? Because when I hold, I generate a tension. When I hold these two, I generate a tension of 20 newtons. So 20, 20, 40 here, 20, 20, 40 here, but I have weights of 40. So when I leave, they balance, so nothing moves. So let us see. When I have 4, 4 and 2, what do I have on top? I have 5 into 4 into 4 into 2 on top with a G. And on the bottom, I have got 4 into m2 and m3, so that's 8. Then 4 into m1 and m3, so that's 8 again, plus m1, m2, so that's 16. So what do we have at the bottom and on the top? So we can cancel this 4 into 4, 8 into 4, 8 into, so we can cancel 16 all over first of all. So this 4 and 4 cancelled, 16 cancelled, so 2 remains over here, 2 remains over here. So we have 5 into 2g on top, and we have 2 plus 1, which is 5 at the bottom. So what we get is 2g. The tension is equal to 2g, which we had thought is the situation, meaning to say that this equation is perfectly all right. Otherwise, all these cancellations would not have happened and we would have not got what we are getting, what we have already gone through analysis and got. So this massive equation, One could have gone wrong in any step. But putting a logical value, 4 for this, and 2 for this, you are able to cross check this equation, and you have to analyze that t should come 20, 2g, t should come equal to 20 or 2g, and it is coming equal to 2g. It should give you a lot of satisfaction. So in several ways we have seen that what we have done is all right. So that is the way you solve a question. Analyze and then put the equations. It is not simply blindly writing the equations. There is no hurry of just getting the answer. Once you get the answer, analyze what is happening, soak in the situation, make the things little tough. You can add weight to the pulley and spend a lot of time on a single question by doing some variations. That is how you learn the chapter. So in physics, I am not asking you to do many questions. Even if you do few, do it well. Have a lot of thought process going into that.